Next up, we have the esteemed CEO of NEBRA, who has been revolutionizing proof aggregation by building the UPA, Universal Proof Aggregation Layer. So welcome, Shumo.
Great. How's everyone doing today? Let me ask you a question to understand who are the audience. Raise your hand if you write a Solidity code. Have ever write any Solidity code? Okay. Raise your hand if you write a ZK circuit. Okay. Raise your hand if you write a snark paper. Musu, you didn't raise your hand. Interesting. This is for you. Today I'm going to talk about universal proof aggregation for scaling, privacy, and interoperability. So this is outline. So I will go through why we're building the universal proof aggregator and what is UPA, how does it work, and then to tell you how about like UPA for interoperability. First, why UPA? So this is a ZK supply chain in our view, right? So the normal paradigm ZK getting on chain is there's a user, and the user gives some input to the prover, and then prover send the proof to the verifier. And today, I think most useful ZK applications, the verifier is deployed on chain. And then there are two kinds of applications in our view. One is this privacy-preserving applications. For example, Aztec. For example, Raremode. For example, WorldCoin, or like Tornado Cash. So in this kind of applications, the proof generation happens on the client side, and then the user need to send the proof on chain. And then for all the scaling applications like ZK coprocessors, ZK EVM, storage proofs, so on and so forth, the input is due from the user and from like some public blockchain history, and the prover is run in some big boxes in data centers or in their like a server infrastructure, and then they put the proof on chain to verify. So why we're building UPA, because we actually believe in 10 years, many applications, including blockchain, is going to be powered by proofs. And we have many proofs, and then it's very important to scale the processing power of the blockchains on these proofs. So one of the biggest issues is that the current blockchains doesn't scale in terms of processing proofs. So here, this is examples of how many the dollar cost of you verify a proof on chain. So for example, if you verify a Gross-16 proof, roughly costs about 250K, which is more than $20, and Halo 2 KZG more than $30, and Stark proof more than $100. So this is a famous quote from Vitalik. He was saying, do you want to pay $20 to add privacy for your on-chain transaction to buy coffee? And probably not. So that's basically why we're building NEBRA UPA. So then what is UPA? So UPA is short for Universal Proof Aggregator. The whole idea here is that it takes proofs from different parties. We call it universal because currently it can handle different circuits, and in the future, the proof from different proof systems. So you can have many proofs. For example, proof from ZK EVM, proof from privacy-preserving applications. Remember the proof supply chain. So we want to, the reason why I focus the interface on the verification layer is just like try to be unopinionated as possible. And then we will using NEBRA UPA to build these recursive proofs, or people call it aggregated proof, which means this proof contains a statement of the successful verification of all these proofs into a single proof and put it on chain. And our architecture is specifically designed for Ethereum, despite it can be used on other blockchains. So the fundamental why we're building this protocol is not just from the technical side, it's also from the economy side. So essentially, we're actually building the shared economy of proof aggregation, which means it's kind of absurd, but more proof you have, the more proof you aggregate, the better economy, because each individual proof getting verified at a much, much lower cost. So this is the fundamental we're building this protocol. Let's get a little bit into this protocol, slightly more details. So first, it's permissionless. We're not building a SaaS company. So the interface is just a smart contract address you can call. And this smart contract address should be persistent over different kind of blockchains, like different Ethereum layer 1 and L2s. And secondly, it's actually censorship resistance via a forced inclusion mechanism. So this gives us power to supporting many like privacy-preserving applications. So they don't have the worry that we censor their transaction. And last but not least, it's actually progressively decentralizable. One thing we particularly care about is a developer interface. So in the sense that using NEBRA UPA is very, very simple. So on the left-hand side is how you verify a proof before NEBRA UPA. So you have kind of like a proof generation mechanism, and then you write your own proof verifying contract, then put it on chain, then call the verification. And using us is roughly the same. The only difference here is that you replace NEBRA UPA as your proof verification stack. In your proof verification stack, you register your verification key, and then you can start using us to verify your proof. So we actually launched NEBRA UPA on testnet about 3 months ago. So the detailed construction is we're using like 2+ layer recursion in Halo 2 KZG. And we actually built a pipeline and distributed prover serving architecture to make the recursive proof generation extremely fast. And let's talk a little bit about the infrastructure, the backend infrastructure powers NEBRA UPA. So there are two ideas here. First is the distributed proving, which means the proving workload is actually being distributed among different servers. And each server, we're running a state-of-art GPU, which is like a 4080, to accelerate the ZK proof generation. So there are two kind of first layer circuits. One is UBV, we call it the Universal Batch Verification Circuit. And the second is CACHEC. We basically handle a universal CACHEC circuit handle the public input. And then each circuit are actually running in its own machine for parallelization. And then all these proofs is pipelined to the aggregation circuit. So by doing so, we can get maximum the minimal latency because all the provers is running at the same time. And also, we have a pipelined proof serving architecture, which means we can overlap improving different batches. So for example, when the batch 1 comes, our coordinator will spawn a prover cluster. And while the prover cluster 1 is working, if at the same time the batch 2 comes, then the prover cluster 2 will be spawned, so on and so forth. I guess as a result, we can handle extremely high throughputs zero-knowledge proof verification. In last December, we actually did an experiment on Sepolia. We can handle more than 1 million proof over less than 36 hours. So, which is like more than 10x of the current Ethereum's proof processing power. I will do these 2 slides pretty quick. So there we overcome many, many challenges building NEBRA UPA. The first is well known among the cryptographic community is non-native arithmetics because the finite field size in the proof is not the native data type of the finite field you are writing in the circuit. So this is roughly give you about like 20x blow up in the circuit size. And second is that we want to handle heterogeneous proof, not just for better system, also for better economy, in the sense that the more proof system we can support, the better shared economy we can build. So in the sense that in the NEBRA UPA 1.0, we already support all the 3 major versions of Gross-16, and with arbitrary size, the public input. And the NEBRA UPA 2.0, we're going to support gross 18 and all the kind of variance of Planck, and also Stark as well. So in the NEBRA UPA 1.0, we're using a circuit-based infrastructure, but we're actually moving into a VM-based infrastructure. So there is a trade-off between the developer time, latency, and prover cost. So here basically we want to make the infrastructure fast and also versatile. So our solution is that we're using a ZK VM and adding precompile so that this precompile is specially designed to help the ZKP verification and making the non-native arithmetic more efficient. So this is why we're building UPA and what is UPA. So I think you can think UPA is a huge unlock for all the ZK applications, because instead of paying $20 proof, you are paying $2 or even less proofs. So this is important for infrastructure, but also this is important for privacy applications, because currently one reason that blockchain privacy is lacking right now is the price for privacy is very, very expensive. So I have 5 minutes left. Let's briefly talk about UPA for interoperability. And here I think one of the biggest problems in our space is we're lacking a native interoperability, which means for many, many transactions, you need to go through bridges. So for example, one of the biggest issues we can see here is that despite for all the rollups, they have native bridge on L1. But if you want to send your asset from L2 back to L1 or across different L2s, so this is still a huge pain as today. So we think like the native interoperability would be defined by like making cross-rollup transactions as the first-class citizen and to be part of the settlement, and also be part of the settlement. So that's where proof aggregation coming through, right? So this is the high-level infrastructure. How can you using proof aggregation to build a native interoperability layer or a new ZK stack? So I will go through that very briefly. So basically, you want a coordination module, and all the cross-chain, cross-rollup transactions can be sent here. And then basically, the responsibility of the proof aggregation module is to ensure all these cross-rollup transactions, which usually is a bundle of the transactions sending on different rollups, can be settled safely. In the sense that you can think of the proof aggregation module as kind of a bouncer, because ZKP is used for the safety check here. Basically, if all the participating rollup doesn't put your like a cross-chain, cross-rollup transaction bundles, and their state root is getting rejected. And then because we have proof aggregation, we can support many, many rollups. For example, we can potentially support more than 1,000 rollups, ZK rollups working together, and then give them native interoperability. And here is an incomplete list of what's the benefit if we have native interoperability. So we think this is an ecosystem-wide unlock. So first, we can fix many, many security leakage by the bridges. And also, we can bring enforceable cross-rollup intent. Basically, intent can be modeled as a state predicate over the blockchain state. And also, we can have better developer experience for chain abstraction, for wallet builders, and then we can bring better capital efficiency for cross-rollup market makers. And also, to launch up a chain is a very big job, because it's not only just launch up a chain, also you need to bootstrap the liquidity. So basically, have native interoperability, we can lower the liquidity requirement to start a new chain because you are the part of the ecosystem. And next, so we could also enable new use cases, for example, like pure asset chains, in the sense that today, all the rollups are general purpose rollup. And by using native interoperability, you don't have to. You can be hyper specialized. For example, you can just be an asset issue chains. Or recently, there's like a proposal from Vitalik called like K-store rollup, right? We can see many, many specialized rollup getting. And last but not least, right? So like native interoperability, in my view, can lower the friction and bring the better UX to the end users. So with that, I will come to the talk, and this is my Telegram. Welcome to join to chat with me if you are interested. Thank you. Questions?
Do you also support like Spartan proofs like that? And what is the final proof? Like what's the family of proofs? The final proof that you aggregate, what is it?
So the question is, are we supporting Spartan proofs?
Yeah. And in addition, also, what is the like what will be the last proof?
Yeah. So in terms of the proof we support, which is the input of the NEBRA UPA, currently we support all three different versions of gross-16. One is the like a Snark JS gross-16, and one is Bellman, and one is Gnark gross-16. They have a little bit of the actual commitment point here, basically using the idea of Nagel Snark. And for the output, currently it's a Halo 2 KZG proof, but it's a specialized KZG, which is very fire efficient, which means we're only using one column. So it's only like 400K. So I think we are moving to a ZK VM-based architecture. So the input proof will be much, much wider. So we'll be supports the major Plunk, for example, Valida Plunk, Flunk, and also Honk from Oztech, and various different like proof systems. We're probably gonna support Spartan in V2 if we see a big need. And also, last but not least, we will be deployed on Ethereum about in 3 weeks for mainnet, and also we are committed to deploy on the major L2s like Base or OP. Yeah.
Yeah, so I've got a question for you. A lot of the costs are in ZK rollups right now. And so the ZK rollups, some of them they have like fancy new groups like FRIs or Starks, and then they wrap them in a ZK Snark so they can use the ZK primitives on Ethereum. Now, if those ZK rollups were other people are using apps that can be aggregated from NEBRA, it might be possible to convince them to remove that final Snark package, which adds to the proof generation costs and adds nothing to the overall proof and verification itself. Is that something that you think is possible to get some of the ZK rollups to do?
Oh, totally possible. Totally possible. So basically, because you have this like open, so basically they're doing their own proof aggregation, but it's very specific kind because they're only aggregating the proofs from the same circuit. By using universal proof aggregation, you don't have to do your own aggregation because we are an open protocol for everyone, so you can have the shared economy with everyone. So one example is that, for example, one of our big customer is a WorldCoin, so they are generating 1 million proof per month. So if we deploy on OP, basically aggregating their proof, and a lot of people can just catch the train kind of for free. And not really for free, but you have a good latency and also like a cheaper cost, for example. Yeah, totally. I 100% agree. Yeah. Thank you.